Now that we're familiar with what a relation is, the next thing we're going to do is we're going to talk about functions. Now, the first thing to keep in mind is that any of these things that we drew or listed, any kind of diagram you can come up with, all of those are relations. And all relations have both a domain and a range, a set of x's and a set of y's. However, not all of them are functions. Only a portion of them are actually functions. So a function is a relation where each x in the domain is paired with exactly one y from the range. A function is a relation where each x in the domain is paired with exactly one y from the range. If you need to pause and write that down and then turn it back on, go ahead and do that. One phrase that I want to make sure that we're clear on is we're saying exactly one. Exactly one means exactly what it sounds like. That means one and only one. So every x in the domain gets matched with a y value, and that's it. So when we're looking at these 5 relations here, some of them are functions and some of them are not. What we're going to do is we're going to think about if I am looking at this list of ordered pairs and I see that my x value of 2 is matched with 3. What I'm going to do is look at the rest of my list and see whether or not an x value of 2 is ever matched with anything other than a 3 for y. And it's not, it's only matched with 3. 1 is matched with 4. If I check, 1 is never matched with anything else. 0 is only matched with 5, and the x value of 0 is never matched with anything else. So what that means is every x in the domain is paired with exactly one y from the range, which makes this example in the top left corner a function. If we look over here at this diagram, our definition of function is that each x from the domain is paired with exactly one y from the range. So again, I'm going to think about x value of 1. I pair it up with 3 for y. The x value of 2, I also pair it up with 3 for y. But by definition, each x in the domain is only given one y from the range. Okay, it doesn't say that it has to be a different y. It just says that I can only give an x value of 2 one y value partner, and I did. I only gave it 3. It says I can only give the x value of 1 one y value partner, and I did. It just happens to also be 3. Okay, by definition, here in this diagram in the top right corner is also a function. And it's the x values that we're focused on. We don't care where the arrow goes over here as long as there's only one ending point for each of our x's, one y value. When we come down here to the bottom left, this says I'm going to match my x value of 5 with 3. And then what happens when I come right down here? It says, well, now I matched 5 with 4. Okay, so even if I didn't have these other 2 points down here, which I still do, of course, but I've given the same x value 2 different y partners. So by definition, that means this example, this relation right here in my table is not a function. When I have a list, or a table or a diagram, what we're looking for are the x values to repeat. And it doesn't matter if the y values repeat all day long. Okay, every x value can all be matched to the same singular y value, every single one. Okay, it's the x values that can't repeat. So there's no repeating up here. There was no repeating right there. But here I have 2 5s in the x column with different y's. So that's when I stop and say this is not a function. When we're dealing with our infinite sets, like the picture of the line and the picture of the circle, then what we're going to have to do is kind of, we can't just look at a list and look for a repeated x value. So I have to think, if I'm standing right here at this value of x, how many points on this line have that particular x value? and I find that one. And I say, well, what about this particular x value over here? If I come down here low enough on my line, here is 1 point, but only 1 point that has that value of x. And here is 1 point, and here is 1 point, and out here would be 1 point. So in my mind, I have to think, can I ever think of a place that I would stand for x that there would be more than one y value that goes along with that particular x? What we're going to do is what's called the vertical line test when I'm looking at a picture. Okay. And I'm not going to write down all the details of the vertical line test here. It will be in your book. You'll need to look for the appropriate shaded box or the boldface print. But the important thing is, remember, your vertical lines go up and down. Okay, vertical lines go up and down. And so what I'm going to do is either physically draw vertical lines through my paper. Of course, I have the whiteboard magic here where I can just drag it around. But I think about drawing a vertical line. And then I think about putting it through my picture, my graph of that blue line there. If no matter where I put this vertical line, it only intersects my blue graph in 1 point at most, then that means this is a function. But if I can find even one place to draw that vertical line where it intersects my blue graph in 2 or more places, then I say it fails the vertical line test. I'll say this is not a function. So that doesn't mean every place I draw my vertical line it has to cross twice. Out here, it doesn't cross at all. Not in my domain. Here it only touches once, okay, which is fine. But if I can find even one place where it crosses 2 or more times, then I stop and say, well, that's not a function. So if I'm looking at a list or a diagram, I'm looking for repeated x's. If I've got a picture, I'm going to do the vertical line test. So let's look at this relation right here. And the 3 things that we're going to decide, is it a function or not a function? What is the domain of this relation? Because it will have a domain and it will have a range, no matter whether or not it is a function. Okay, is what we did in the last video. So I want you to pause the video here in a moment and decide whether you believe this is a function or not a function. Tell me what its domain is. Tell me what its range is. Okay, when you turn the video back on, I'm going to have all those 3 things there, so be ready for the answers. Okay. So if we're checking to see whether or not it's a function, we're looking for repeated x values. And that doesn't mean that it says 1, 1, 2, 2, 3, 3, 3, 3. Okay, what that means is we're looking for these arrows that leave. Okay, only one arrow leaves the number 1, so 1, 4 is one of the ordered pairs. But notice right here with the 2, there's 2 arrows, 2, 5 and 2, 6 are both on our list. So what that tells us is that this function is not, this relation is not a function. When we're after the domain is the set of x values. And again, if we have a list here, we're going to make a list. And so the x values that show up are 1, 2, and 3. We're going to do the same thing with the range. Range is a set of y values. And even though they didn't label this time and say, hey, here's our x's and here's our y's, notice the direction the arrows are going. The first coordinate in our ordered pair is always considered to be our x, and the second one is our y. So here is the next example. I'm going to ask the same 3 questions. Is this a function? What's its domain and what's its range? And so go ahead and pause the video, write it down what you believe, and then turn it back on when you're ready to see it. Okay, so when we go to decide whether or not this is a function, we can do the vertical line test. If we can draw vertical lines. And we say if I can find even one place that it crosses that vertical line, the vertical line crosses the graph 2 or more times, then it's not a function. So this one is not a function either. The domain is the left end of the graph, comma the right. and it touches everything in between the values of -5 and +5. For the range, that would be the bottom of the graph, comma the top, and the lowest point on the graph is -3 for the y, and the highest y value that shows up is a +3. And since it touches everything in between, here's touching 2.9 and 2 and 1.5 and 1 and 0.7 all the way down, okay, to -3. Go ahead and do the same thing on this one. Pause the video. When you're ready, turn it back on for the answers. On this example, no matter where I draw my vertical line, it's always only going to intersect at most one time. Okay, sorry about that. Okay, at most it's going to intersect one time. There we go. Okay, so yes, it's a function. For the domain, these arrows indicate that the graph continues on and on and on. And even though it's not getting wide super duper fast, notice it is getting a little bit wider as we move away in both directions. Okay. Again, not quite as extreme as what I just sketched, but it's going to go to the left forever, it meaning the graph, and it's going to go to the right forever. For the range, we're looking for the lowest point of the graph, comma the highest point in the y direction, and so the lowest point on the graph is -infinity because it continues down without ever stopping. The highest point on the graph is a y value of +4. Right here I have the y coordinate of +4.